Translate chemical equations, we need to understand the symbols used in chemical equations. An arrow is known as a yield sign, and it's used to separate the reactants from the products. Reactants are always found on the left and products are always found on the right, even if it's a reversible reaction. If you see a phase notation, S, L, G, or AQ in parentheses, it lets you know what phase your substance is in. So AQ in parentheses stands for aqueous, which means that it's been dissolved in water. S in parentheses means it's in the solid state, L would be liquid state, and G would be in the gaseous state. You might also see an up arrow to represent the gas. If you see a triangle or the word heat above the arrow in a reaction, it means that heat is needed for the reaction to occur. Sometimes you'll see something written above the arrow, and that indicates a catalyst, which is used to speed up the reaction, but is not consumed by the reaction. So it would be right here above, sometimes below the arrow. If you see two-sided arrow, that indicates the reversible reaction, and this is described as being in a state of equilibrium, which means the forward reaction occurs simultaneously while the reverse reaction is occurring. These are still the reactants on the left, these are still the products on the right. Now let's look at translating words to formulas. There are several things to watch out for when translating words to formulas. If you see just an element, you simply write the symbol of that element. So if you see the word aluminum, just write Al for aluminum. Iron, Fe, silicon, Si, just for a few examples. If you see one of the 7 diatomic elements, then it has to have a subscript of 2 next to the element. So for example, if you see nitrogen gas, you're going to have to write it as N with a subscript of 2. Like this example of oxygen gas is O, but with a subscript of 2 to denote that it's a diatomic element. Now a review on writing the formula of an ionic compound, which is a metal plus a non-metal. You have to balance charges. So for example, lithium has a charge of a positive 1 and phosphide has a charge of negative 3. To balance that, it takes 3 positive 1s to equal this 1 negative 3. And so the formula would be Li, subscript of 3, P for phosphide. Calcium chloride, charge of plus 2 versus charge of negative 1. It's going to take 1 calcium at a charge of plus 2, and it will be balanced with 2 chlorides, each at a charge of negative 1, and so the formula is CaCl2. Similarly here, a positive 3 versus a negative 2 charge, 3 times 2 gives me an overall positive 6, 2 times 3 gives me an overall negative 6, so we're going for the common factor of 6. Therefore, aluminum would have a subscript of 2, oxide will have a subscript of 3. When your charges are equal and opposite, it's a 1-to-1 ratio, or you can think of it as the charges cancel. So a plus 1 minus 1 is going to cancel, which means you just need 1 lithium, 1 chloride. You just need 1 of each, cation and anion. Plus 2 minus 2, I just need 1 of each, 1 calcium, 1 oxide. Plus 3 minus 3, 1 of each, 1 aluminum, 1 phosphide, no subscripts necessary. So recall on the periodic table that if you have group 1, they have plus 1 charges, group 2 has plus 2, group 3, which is pretty much just aluminum, has a plus 3 charge, and then over here we have our anions that end in a suffix of "-ide", nitride, phosphide, arsenide, oxide, sulfide, selenide, telluride, fluoride, chloride, bromide, iodide. These are my anions, monoatomic, only 1 element, as opposed to this list, which are polyatomic, 2 or more atoms combined with a charge overall. So here is acetate, ammonium, NH4 with a positive charge, and so forth. Anytime we combine a cation with any anion, we have to make sure charges are balanced. If you ever need more than 1 polyatomic, it's going to require parentheses. If you have a covalent compound, it's a nonmetal plus another nonmetal, and so we use prefixes as the subscripts. There are no charges in a molecular or covalent compound. The prefixes are the subscripts. For example, diphosphorus pentoxide. Phosphorus is my first element, and di tells me it has a subscript of 2. Pentoxide, oxide is my second element, or oxygen, and pent tells me it has a subscript of 5. So it's P2O5. No charges to balance, just prefixes equal subscripts. If you have an acid, it's going to start with hydrogen and you have to balance the charges. If you see the name of an acid starting with hydro, like hydrosulfuric acid, then there is no oxygen. And so you're going to have hydrogen, which has a +1 charge, and then this is sulfide, IDE, because there's no oxygen, and so it's going to be S with a -2, and then when you balance the charges, we have 2 hydrogens to every 1 sulfide. If you see no hydro in front of the name, such as here and here, then we do have oxygen in the formula. It's an oxyacid. And so if you think ate, us, so since this is sulfuric acid, then the anion is sulfate. Since this is sulfurous acid, the anion is sulfite. And then you have to balance the charges. Since that has a -2, it's going to mean we have 2 hydrogens in the formula. H2SO4 is sulfuric acid. H2SO3 is sulfurous acid. You put it all together, you're going to have a word equation such as lithium reacts with oxygen gas to produce lithium oxide. And you have to translate it into a symbolic equation. Lithium, being a single element, we'll just write Li. Reacts with is going to mean put a plus sign. Oxygen gas, it's one of our diatomic elements, so we're going to have to put O2. To produce is when we draw our yield sign. And then lithium oxide is ionic because it's a metal and non-metal, so you have to make sure you balance the charges. Since lithium is a +1 and oxide is a -2, when we balance charges we get Li subscript of 2O. Notice that there are no charges or superscripts on any of our final formulas. Example number 2, we have a word equation. Phosphorus combines with chlorine to form phosphorus pentachloride. So since phosphorus is a single element, we just write P. Combines with means plus. Because chlorine is a diatomic element, it's going to be Cl with a subscript of 2. To form is another way to say yields. So we'll draw an arrow. And then finally, phosphorus pentachloride is covalent because it's nonmetal plus more nonmetals. So the prefixes equal the subscripts. So to write this, we'll put phosphorus P and then chloride Cl, and then the prefix of penta means it has a subscript of 5.